Hi, my name is Karin. I'm a self-taught iOS developer, and I have been using SwiftUI and Combine extensively since it was announced in 2019. And in this course, you and I together, we are going to learn the basics of the Combine framework. Now, this course is for absolute beginners. There's no need to know anything about functional reactive programming or the Combine framework. We will start right at the beginning. The first thing you have a look at is subscriptions. How do you create one? How do you create a data stream from passing values? And how do you cancel it if you don't want to process anymore? Then we are going to have a look at the different subscribers that we can use. So we use assign and sync. Since Combine really shines when we use it for asynchronous code, I also will start to tell you a little bit about the multithreading. So how can you change the thread inside of your data streams? How can you switch to a background thread, and how can you come back to the main thread? Because you want to have the data to display it on the UI, and we have to do that on the main thread. One of the difficult parts, one of the things that I had trouble with understanding is taking user input like text field enters, buttons, or clicking or checking a checkbox, and processing these inputs in a combined data stream. And one thing you really need is a publisher or something that starts your data stream. So this is the second part of this course. We have a look at publishers, and in specific, the most important publisher for when you want to start a stream continuously, you want to send values like from user input, and that's subjects. So we have a look at CurrentValueSubject, PassthroughSubject, and also publishers that you can create with a add_published property wrapper. And you will also see what's the difference between those three and what are their commonalities, how we can use this. And to really understand data streams or get a sense of data streams, we'll also at that point have a little demo, or actually it's two demos. One example to use Combine for UIKit, and the other one is for SwiftUI. And even if you're only interested in one of them, I would still encourage you to have a look at both of them, because you can learn from each other. If you are into UIKit, you can have a look at how does SwiftUI do the combined data streams? How does it do this binding between properties and views? So you have an idea of what is possible and what you could implement as an example. And if you're into SwiftUI, you're not aware of the data flow that is going on. What kind of combined data streams are used in SwiftUI, because it's behind the scenes, it's done for you. So it's nice to see UIKit as how would we implement it if we had to do it ourselves. In that situation, we'll see where the subjects and these add_published property wrappers come into play. I did prepare some exercise files which you can download from the link in the description box. And there's 2 playgrounds and 1 starter project for Xcode. So now let's start learning Combine. So as a rough overview, what we are trying to understand in this section is how do we create a subscription? We will see the 3 ways of creating a subscription. Also, we'll see how the data flow works with the subscriptions. Then next question is, once you have a subscription and data is just coming and coming, at some point you might want to stop executing. How do we stop a data stream? And we see a couple of things how you can stop a subscription. This is important because we also want to write our code in a way that we free up resources as soon as we don't need them anymore. So we need to understand a little bit of the organization of the code. Then we have a look at sequenced publishers, or publishers that are limited in how much they are actually going to produce on values. And then further down the road, we're going to talk about multi-threading and Combine. Let's get started and go in the first playground page, which is creating subscriptions. This playground is pretty much empty. I only imported here Combine and Foundation, which I need. I want to now show you one publisher that illustrates the data stream behavior a little bit nicer, and that's a timer publisher. They added to the Foundation framework a couple of publishers that we can directly use. So you can use timer.publisher, and here you see every on-in. So we have a every in time interval, and this is in seconds, so we can say every half a second. Then we have to use the scheduler. So I'm using here main and the mode, and we're setting this to common. So this is a publisher, and if you have a look at the type, it's a timer time publisher. This by itself won't do anything because it doesn't have a subscription. It needs to receive a subscription to start working. The other thing is with these timers is that you need to tell them to auto-connect because they are waiting for a start signal. So I have now a publisher, but I need to create a subscription, and we use sync. And you see here we have a sync receive and a sync receive completion with receive value. And I'm going to use the second one because this gives us even more information. So the first closure here is the completion information. So I'm going to print here data stream completion. And we're going to print this completion. The second one, the receive value, is called whenever this timer publisher emits a value downstream. So this is actually a timestamp. And we're going to print here received value. And then we're just going to print here this timestamp. So the output of this sync here changes this publisher, if you have a look at this, to any cancelable. So I'm just going to, you don't need to write here what type it is, I'm just typing it here so you know what we have. Any cancelable is something that you can call cancel on to stop it, because if I now here run my playground, you can see it starts emitting values, and from the print statements you see this timestamp. And if you have a look at the seconds, there's 2 values per second because I said here 2. It's maybe a little bit easier if I change now emit a value every second. So now you see every second we receive your value. We then stop, and this is going to continue onwards because this publisher just keeps on publishing. Why would it stop? It's just keep on going until we cancel our subscription. How do we stop this publisher from publishing values? Similar to a publisher only emits values when it has a subscription, we can delete or remove the subscription to this publisher and the publisher will also stop. So for example, after a couple of seconds, dispatch queue main.async after, this is now plus, let's say, 5 seconds. So after 5 seconds, I want to stop my publisher here, and we're going to use the publisher. Actually, I should probably rename this here. This is not a publisher, this is a subscription. I can call my subscription to cancel. If you run this again, we get again these 5 values, and then it stops to emit because we told it here. And we simply canceled it. We don't even see this completion handler here because we just left it. The other way of canceling a subscription, this subscription is alive as long as we hold a reference to it, which means if I make my subscription now here in optional, instead of calling here cancel, I can say subscription is null. And I have to make this here a var, otherwise I'm not allowed to. So now I'm allocating the reference to the subscription after 5 seconds, and we run again. So I see one timer value coming, 2, 3, 4, 5, and then this subscription is allocated and I stop, this timer stops. So we have now seen here 2 ways of canceling a subscription. But we also saw the way of actually keeping our subscription by keeping the reference to the subscription. This stream is not really interesting. I'm only here seeing timestamps. And in this case, maybe I'm more interested in counting the seconds, like making a actual timer. In order to not receive here timestamps, but timer countdown numbers, we need to manipulate the value that is passed in our stream. And that we do with operators, and I'm going to show you one operator that will help us in this situation, and it is scan. So if you type scan, you see here we have one operator which has an initial result and a next partial result. Our initial value when we start a timer, if you start a timer, you start by 0. So this is 0, and then you press on the next partial results, enter. So the first value you get here in this closure is the last result from the last loop. So in our case, this is the count and the output from our timer publisher here. So this is, we can use here for calculations or timestamp, but actually I don't really need to. I just want to be called here. And what I'm going to return here, what I'm going to do is I'm simply returning here my count plus 1. Which means that every time I'm going through here, every time a value is passed for my timer, I start with 0. The first time this value comes, the count, which is 0, is taken and we're adding a 1. So we start, it's the 1. The next time my timer is passing a value, we are the old value, the count is 1, and we add another, so we add 2. Which means that this scan operation is accumulating all the values, so it's going to add up over time. Okay, let's see and run this. So now you see here, actually, I need to do this again so you see the values better. Now here on the side, you can click on this I sign or on the pad. If you click on the pad, you see a little diagram or the values during the emission. So it's 1, 2, 3, 4, 5. So you see how each value, you can see how each timestamp that is passed here is triggered. Every time one is passing, it triggers our scan and we add one more to our counter. You can now think of how can you make this timer trigger faster, and that is one solution and the solution is to change here the timer publisher, the interval for how often it's emitting a value. So if you go back to half a second and run again, you see that I get a lot more values here until again here my 5 seconds is over and then we stop. But maybe I don't want to always. One of the advantages of this data streams is that we can manipulate if we want to let a value pass or not. So you can put in barriers that you don't want to process. One of them is, for example, filter. So in this case, we have to specify a condition that says true and let this value pass. If it's false, then it's not going to be going to our sink here. So we get here our count that we had that we calculated in the scan, and we can say return if, let this pass if my count is smaller than 5. I don't want to go so high, so stop at 5, or actually before 5 even. If I want to stop at 5, I need to say here below 6. So if we run this now again, and I here again click on this pad icon so I see now the value. So I need to do this again. So now we start 1, 2, and this condition is true, and then as soon as we hit 6, it's false, and these values are not passed down to our sink, which we see down here because our receive value print statement is not triggered. So we can decide how much values we want to actually have, and you can also filter by time. So you can say I only want to have one event in 5 seconds. Because maybe what I do here in the sink is really expensive and I don't want to do the work. Now our stream is triggered by a timer, but in the application you have a user interface with buttons and the user presses on the buy button. And because this takes time for you to ask your server to verify that he actually can buy this, but you don't want to trigger this action all over again. And like this you can narrow down these kind of events that you want to have. You can even, which would not work in this example, but for the buy button, say remove duplicates, which then doesn't process the same actions all over again. Here this is not working because I am always having different values, but I could, for example, use something that limits the amount of events that are passed in a time interval, and this is with throttle. So you can say here in the time interval that I only want to have one event, and we already said that maybe I should 5 seconds is a bit too much, but let's say one event per 2 seconds is fine. Then you have to specify the scheduler. So for this we can use the dispatch queue main, dispatch queue.main, and now you can even say inside of this 2 seconds there's going to be a lot of values. Do I want to have the first one or the newest one? Let's set this to true and we see which one comes through. So now you see here, actually I probably want to change the position of my throttle to be before my scan when I always add an element. Otherwise I will see here some jumps, which you see here now, because it's counting, but only when 1 in 5 is passed through. So we're going to move the throttle before the scan. So we start here. You see it's a lot slower because not all of these elements are let pass through, so only every 2 seconds we see an item, a value. So my timer is emitting every half a second a value, but my throttle only lets one pass every 2 seconds. So you see here these values coming through every 2 seconds. My filter here is always true, and it never reaches this limit because I stop my my timer before that happens. So I'm just going to increase this here to 20, so we can see everything. So we're emitting values. We only let them pass every 2 seconds. We add our elements up. We filter because we don't want to proceed with everything. And then we stop we cancel our subscription here after 20 seconds. This stream doesn't really do something super fantastic right now. I just wanted to give you an impression of the purpose is more getting a sense of there's data flowing, and we can manipulate and we can decide what we let through and what we pass and what we actually do with it. Calling here cancel on the subscription is one way for a data stream to end, but there's actually another thing that can happen, multiple other things that can happen. If we go in the second, on the limited subscription page, you see here a different publisher that I created. When you have an array, like an array of strings, you can add a .publisher and this will create you a publisher. And this publisher here, I'm just going to put this here so you see the type. This is a sequenced publisher that publishes strings and never fails. Because why should this one fail? There's nothing wrong with it's just strings. So now let's use this food bank publisher in a subscription. So we're creating a subscription. So we need to keep reference to the subscription. Food bank, and we create this subscription by adding again sync, and this time receive completion and receive value, because we actually never saw something happening with this completion. So I'm going to print here completion if this completion is called completion, and if I receive a value, which is a food item in this case, I'm going to print here receive item, which is my food item. So that's it. Let's run this. And this one fires really fast because it's just going to go through all these arrays, and for each of these elements, because we are having here a sequence publisher, it's publishing each of these items into the stream. So you see here in our print statement that the first item it publishes the first one in this food bank array, just the apple, then it passes down bread, and it passes down orange, and it passes down milk. And now the interesting thing is here you see this completion print statement. So in this case, this publisher already completed. If you think about it, if you have a sequenced publisher or something like this array, would you expect this to publish forevermore? Or do you see that it's publishing a couple of things and then it stops? It only has 4 elements. It's not going to hang around for much longer. And since my subscription here, I don't want to waste my resources for waiting for new values, it also doesn't make sense to keep the subscription. So the way they made it is that the subscription, as soon as the publisher says, I don't have any more stuff to publish, it just releases the subscription. So that's really handy if you have something that automatically should finish. You don't need to call cancel on it. Then the question is, if I have some of the publishers like this one that is limited and some that are just keep on going, what can happen if you try to combine them somehow? So in this example, I'm just going to comment out this subscription here. And we are going to use the same one as before, this timer subscription and the timer publisher. So this is a timer. So I'm going to use my food bank publisher and I'm going to zip it with another publisher. You will see in a minute what the zip actually does. This zip here expects another publisher. So I'm using here the timer. And then I'm going to call here a sync again with this completion. And actually, I'm just going to use the same sync as before. So we are going to see here this completion. And in this case, because we are zipping up 2 publishers, we are combining 2 publishers, what should be the value in the stream? And it's actually a tuple. So you have 2 things. The first is the food item. And the second is our timestamp from our timer, or the value from the other publisher. Timestamp. So we would here see our timestamp. Okay, now the question is, I'm here combining 2 publishers. One will finish and the other one won't. What happens when I zip them up? What I see in my stream here is that this zip is combining values from these two publishers and is actually pairing them up. So you have for each, in the beginning, my food bank can just emit all of his 4 values. But the zip is actually preventing this from directly happening, because what zip actually wants to do is it wants to zip up like a zip. If you have a zip, it's always trying to have the same amount of each side. So it wants to pair up each of my food items with one of the timestamps. That's why you see here, actually maybe I should just make this slower so it's a bit easier to see. So the first one, it's sending the apple because it has a timestamp. Then it gets another timestamp which it can pair up with the bread. Then it gets another timestamp that it can zip up with the orange, and then another one with the milk. But then, because it always wants to zip up things pairwise, the subscription, there's no way it can zip up any more timestamp with other food bank items, because there's nothing coming out. That's the reason why I named it food bank. If you have a food bank and every second there's a customer coming, that you give one element, that you pair up with one element, after your food bank is empty, after you distributed all of the elements, you obviously going to close shop. And that's exactly what the subscription is doing. It's smart enough to know, let's be done with this. So you see here again the case that our subscription automatically cancels because we have a limited publisher. The other thing that I didn't actually say yet is this completion value here. So the completion can have 2 values. It can be either finished. So we can check this with a switch case statement. So this is completion. And then first case, you see here 2 cases, which is finished. This was the case we had already before. So this would be the case of finished. Everything is fine. And then we have another case, which is failure. And in this case, we have here an error, print completion with failure, and we can print also this error, the localized description. So right now I don't have here any failure, so I have to make one. And in this case, I need to have a operator that can throw. And for this, you have this try something operators. So we have here a try map. And if you see here, we get as the two values in this closure, the sequenced, the output of the sequenced publisher, which is a food item. So we are going to change this food item. And the second one is the output. So we have to read it like this: publisher's output. And you see here this timer's publisher's output. So basically this is the timestamp. The typed and this nested publisher stream data can be a little bit hard to read, but I will show you some more things that can help you later. Oh, this is a timestamp, not tramp. So I'm just going to here return a string, because this is also what we had here before. So I can return here a string. This is a food item. And timestamp. So now here it's going to complain because in my thing, since I changed the type of this data stream, what my receive value here gets is one string that I produced here. So I'm just going to name this here result, and I'm going to print this result. So we shouldn't see a difference in this print statements down here, but we now in this map manipulated these two values, this tuple pair. So now I need to decide when I want to throw something, and I'm going to define here a end date. I'm going to use the calendar, which is the calendar.current. The calendar helps me to create a new date, by adding seconds, which is value. Let's say quit this after 3 seconds, and this is date, which is now. So this is when I create this is 3 seconds into the future. So I'm going to now write a function that throws an error. So I'm just going to here define my own error. So this is a struct, my error, and in order to be an error, we need to conform to error protocol. So I'm going to create a function that will actually create me the string here, but it can also throw. So this is function, and it's going to throw at the end date, throw an error at end date. So I need to have here my food item, this is a string, and the date, which is the date. I already said this is a throwing function, and we are going to return normally if it's not throwing a string. So we are going to check if the date is smaller than the end date. And in this case, we are just going to return this string here, and else we're going to throw our own custom error here. This is throws, and this is actually date. And just going to force unwrap this end date. So now in our try map, I just want to, actually the whole point is to have one thing that throws. We're going to return here a trying function or throwing function. So try throw end date, which is my food item, food item, and my timestamp. So just going to run this. We receive one element, and then we see that I get here a completion with failure. So this is the moment, actually, the reason why I only see 2 is because I had here, my timer is emitting every 1 second. I'm going to change this every 2 seconds. I'm changing this here to 1 second, so we see a couple of more print statements. So our timer emits, we zip up 2 elements, and then after 3 seconds, when it wants to emit one again, our end date is reached, and this function is throwing us an error. And you see here our stream stops, because I would have normally 2 more items here to zip up in my food bank. I still have oranges and milk, so I didn't do anything with. But because I have here an error in my stream, this is like a bomb going in your stream. If you have something that it's an error, you wouldn't be able to process anything in there normally. So they made it in a way that the stream is completed. It's like if you have a machine, you would just stop your machine and check what's going on. So if something happens like an error, your stream stops. So this is another way of completing a stream with a failure. We'll see a lot more of these errors when we deal with, for example, here this map operators. If we change the type, if we work with URL session, we will have to talk a lot more about errors, and also how to prevent this, how can we replace an error with something that wouldn't complete the stream. But this is quite a little bit further ahead. Just wanted to let you know that also errors can stop your stream. Now, extensively used sync to create subscriptions, but there's actually another option to create a subscription, and this is this assign. And you see here 2 different ones, and the second one, assign, they only added for iOS 14. So let's have a look at what's going on with this assign to on, and we jump into the playground page assign. And what I did here is I just printed out the definition, and what you have to specify for this to is the reference writable key path. So key path is, you can define the property name of a object, of a struct, but in this case it has to be an object because you see here this reference writable reference type. So classes are reference types, so that's why you can only use this assign to on with classes. This is this example they have in the documentation. It's a very tiny class with 1 property. So let's say I have here these 3 numbers, and I want to do something with them and then put them on this property of my class, or on an int property. So we can create a publisher from this range. This is another sequence publisher actually. And now I can manipulate this. For example, I can multiply this with 10. So I have another number. So the first one, I make the 0 a 0, the 1 is a 10, and then the 2 is 20. So now I have this operator, and I could say sync. This is my value. I could say that I'm on my objects property and int. I'm going to use this new value now for. And since here there's a did set added, so we can see the print statements. So I'm going to print this, and you see that indeed I updated this and int 3 times with these new values with 10 and 20. A different way of doing this is here we can use the assign on, assign to. So in this case, what I want to add this to, what object I want to add this to is my object, and the property name or the key path of this object that I want to assign this to is dot here. This is my n int. So these 2 versions do basically the same. If you run this again, you see again that we assigned new values to an int 3 times. Most of the time you would use the assign to on because it's shorter and nicer to read. But if you don't want to use it, you can just keep on going with sync. This is no problem. In order to not only see this here in this my class is a little bit boring to see. So what would be an example where you can take advantage of this a little bit better? And that's why we go in the next playground page. So just going to run this. you see that I have here a little view controller with a text field. So you have here a text field and a label below. And we have here this text message. It's a CurrentValueSubject, which you will see in the next section what this actually does. It's a special publisher, and this one publishes string values, which fits perfectly because our text field has strings. And in the beginning we have here the text value hello world. So in the view.load, this is just creating this text fields and adding it to the view. Then you see here auto layout constraints just to place this text field and the label. Then I added here a target membership to this text field, so that whenever this text field is edited, or the text inside, we trigger this update text function. And you see here that I'm taking the text field's text and assigning it to my text message. Like this, I always have the same text for my text field in this property, or in this, what it actually is, in this publisher. So I can now subscribe to this publisher and use this text to directly update it to my Hello World label here. Right now, if you type in here, every time you type in here, we do change this text message value, but we never assign it to this label. We never keep our label updated. So, because right now I'm just here one time in the beginning when I run my view.load or load view, I'm one time assigning this text message to my labels text. But I want to continuously do that whenever my text message changes. So we're going to change this line here, and we're going to use our text message because this is a publisher, so we can subscribe to it. And I already said we can use here assign to. So we are going to assign it to the label because this label is a UI label, which is a class. Therefore, we can use it. And the property, the key path that I want to assign this to is the text. It is now complaining that the types don't match because one of them is optional, the other one is not. So I'm going to quickly use one of our operators, which is compact map. If you have an optional that you just want to unwrap, what this compact map does is it's calling the value. And if this value here or whatever you return is null, then it's not passing this value down. And if it has a value, it's unwrapping it and it sends the value as the unwrapped value down the stream. So I have here now a subscription, but I need to store it. I need to keep reference of my subscription because if I leave this function, it's gone. It's similar to allocating this value. So I could now have here a property that I can assign it to, or I can also, they added this, store it in a collection of this any cancellables. So this is this one. You see a set of any cancellables. I actually created here a set of any cancellables. So I can use this store in subscriptions. So this end sign is a in-out parameter that can change the subscriptions. Okay, we have now here our little automatic updating flow that whenever our text message changes, our label is updated. And if you type here, you see that we're automatically updating the label. So every time the text changes, okay, the flow is actually every time you type in here, this target membership is causing this function to call, which is changing our publisher, or it's passing a new value to our publisher. And this publisher stream here is called and changes the value in this text field. So it's a very simple, maybe it's a little bit too simple example, but you see here now nicely that user input is actually the data flow that we are looking at. For example, so instead of just returning the same value, we can use here another map, because once I'm here, I know that I have a value, and we can just add a little string description, you typed, and then I'm just going to add here the string itself. So if you run this again, you see here this hello you typed. The label has now this new string, and it's keeping the string because every time this is called, actually you can also here see the value history. I think if you type here value history, so you see here all the values that I typed, Amazing things. So if you scroll here, you see here all the values that are passed because I typed, every time I change one letter, a new value is passed in my stream. So every time something happens, I have the opportunity in my stream to react to it. And in this case, every time I choose to add something new to my string, or the same thing actually. This is a good example for using assign to on for classes with labels. I will come back to this tiny example also so you know why I used here this CurrentValueSubject. And right now, this target membership is not really nice. We can work on this one. We can also use combine to create a data stream from our text field to our text property or to our publisher. This is the second example for assign to on. And it's quite important because we're going to create a memory leak. I mean, the whole point is that you know how not to actually make a memory leak, but first we have to make one. And in this playground page, assign example, you see here I created a little model, which is a user with a name and an ID. And we have here this class, which is a view model. And in this view model class, I'm just right now holding the two informations that I care about. So one of them is the user and the user's ID. So in this case, I choose to have two different properties here to handle them differently, but they're actually kind of belonging together because if I change my user, I need to have the right ID. They need to always stay in sync. So we again create a little data stream to automatically update the user ID every time my current value subject is changed. So in my initializer, it's the same thing again as in the view.load. I'm going to create my data stream. We want to be notified whenever the user has a new value is passed. And what I don't really want to have the whole user, I only want to have the ID. So we're using map to change this. And I chose the one with the key path because like this, you can easily say which of the key paths or the properties you want to keep. And my user has only two, so name and ID. And in this case, we care about the ID, which I want to assign to. So because my view model is a class, why not put it on myself? And the key path for my view model here, myself, is this user ID. And then I have now this this cute little subscription that I need to keep, and we use the same store in subscriptions. So let's test if this updates. I here have an instance of my view model, and I can say my user, if I want to inject a new value, I need to, with this subject, I'm going to create a new user here. So we had Bob, and this is going to be Billy, and I had the ID 1 before, so this is 2. So when I run this, what should happen is that the first time when I'm initializing this data stream already has one value, which is this one Bob user. So I would, the first time it runs and assigns here to this user ID 1, which it already had, but we will see one print statement with 1. And then we should again see the stream for 2. So if I run this, so you see here I had the first user 1 and then the second user. You can now continuously change the user and automatically the user ID would be there. But I already said I mentioned earlier that we going to create a memory cycle, and we actually already did. So to prove my point, I am here after I did all of these. If I throw away my view model, so I just have to make this here a optional view model to throw it away. So now I'm saying that my view model is going to be null, so be gone, which means that the initializer here needs to be called with everything is fine. And here need to have optional. So let's see. And you see it's actually still around. The init never was called. And the reason for our memory cycle is actually this line here. And in order to see this a little bit better, we're going to go back to our sync. We're going to write this with a sync. So I have here this value that I'm going to assign to this user ID here. I have to say user ID is my new value. But because this is a closure, we need to you see here this warning, we are capturing ourselves. This is quite clear that we here have a memory cycle. So I see again, it's still there. So to resolve this, we are going to use a unowned self. So now I don't hold a strong reference anymore to my viewModel class instance, which means that when I delocate this, nobody has a reference to it. And you see my dinit is called. The reason I'm telling this is if you write a assign on self, never do that. That's actually the rule. I just opened the developer documentation and we have a look at assign to on. Scrolling down. So this is the example I just showed you. I mean the very early one. And here is in this little hint, important, the subscriber assign instance created by this operator maintains a strong reference to object and set it to nil when the upstream downstream publisher completes. When you use this is holding a strong reference to our view model. There's no wonder we had a memory leak here. But you already saw that we can use sync, which means that most of the time you will probably be using sync. And in the end, it's just doing, with sync, you can do everything that you want. You can assign whatever you want to, wherever you want to. And because we have this remembrance of the self here, it's more clear what we're actually creating with this memory leaks. Most of the time you will see me using sync, but I will try to use assign to on when it's appropriate. Let's now have a look at the new assign to operator, which is available for the newer versions like iOS 14 Plus. I just copied here the text from the Apple documentation, so I don't always have to go there and look for it. The good thing about this operator is that this one actually manages the life cycle of the subscription, which means that you don't have to store any cancelable subscription anymore. But this one, in contrast to the use case for this one, is a little bit different, because for the assign to on, we use the assign to on a class property, and in this case you can only use this assigning to here by assigning it to another publisher property. And actually I didn't really talk about this one. So we saw this CurrentValueSubject publisher before, and they added another way of creating publishers, and with this property wrapper at published. And you can use, if you have a property that has this at published, you can use assign to. So in this small example from the documentation, we can use the assign. And now you see assign to. And the thing is, this is a in-out parameter. That's why we have this end sign. So this is in-out is the end. And then in order to create the access publisher of at published, a property that is declared with at published, we have to use a $sign. What we can use here is our $last updated. So it looks a little bit strange with just two signs, but like this, we don't have any memory leaks like what we would have if we would use here assign to on self. I'm guessing they explicitly made it for these cases. You can use this one additionally to sync if you want to. To make this a little bit more fun, we're going to use this here in a little view, because we actually never used our combined code in SwiftUI, and I'm just using SwiftUI because it's also here easier to show it in the playground, simply because the code is so much less than for UIKit code. If you scroll down in this file, I also added here a little clock view, because we have here a timer instance or a class that every second that passes updates this last date. So if we use this in a SwiftUI view, and I also had to make this here observable object, you will see why this is so important for SwiftUI and why this is actually doing something with combine in the next section. But for now, I just want to give you a small little example of where to use it. So I have now here my class instance, and in this view, we just want to show the date here. So you can enter here your date. So instead of this enter date here, I'm going to display here my clock models last date. So now it's going to show me the date as a string, and down here I added the this clock. I created an instance of this clock view, and we set this to the live view of this playground page. So you can also see how to use SwiftUI in your playground. If I now run this, just need to make this a bit bigger. Oh, maybe not that big. So you see here my whole date stamp, and you see also that this time here updates every second. And you can also here, I don't know why it's not, looks like it doesn't like me. So in order to make this even a real clock view, we don't really want the whole string. That's why I also added this date formatter here. Just going to uncomment this, and you see I did define the date by only showing the hours, minutes, and seconds. So down here I can replace this by using this date formatter, string from date, and that was our clock models last date. So now we have this, maybe I should have made this a little bit bigger. Just going to add here a larger font. The thing is, this is not, if you're used to SwiftUI, this is not a preview. It's not automatically updating every time you change something, so you have to stop and start this over again. So now you see my little timer, and we used here a timer publisher to change this property every second to show a new time. And we use then this timestamp in a SwiftUI view, a clock view, to show it just in a text. And the nice thing is, not only are we creating here automatically stream to our property that changes it, somehow SwiftUI does its magic to also automatically redraw the view, because in UIKit, in functional programming, I would every second, not only would I need to update my property here, I would also have to tell the view that the value actually changed. But thanks to SwiftUI's magic, we don't have to do this. It's automatically binding the property to the text. So these were the 3 examples of how to create a subscription with this, how to make a subscription with these 3 different ways of sync, assign, and assign to. Probably should write this like this here. I want to talk now a little bit about multi-threading. This is because Combine is really powerful for asynchronous work. That's what it's, where it really shines, where we really can take advantage of it. Which also means that we need to be able to take care of which thread it's going to process which work. So this is a very small example in this receive on. And you see here I have a subject, so something that I can publish continuously on. And on this is going to publish integers, and it never fails. And I did create here a small subscription with sync. So it's just going to print me the values. I can simply send new values to this subject, and then we are going to see it in the subscription printed here. But what happens if I send now a value on a background thread? Or what happens if I'm using now a different thread here? I'm specifying here dispatch to global. When I run this, I see both of my print statements, but I don't know which thread they're running on. You can check the thread that you are here having your subscription on by asking the thread for the current. So now it's going to print me what thread is actually giving me on. And you see that the first time I'm calling, the first value that I'm sending down here is this 1. And this is done on the main thread, because we didn't specify from which thread this is, so it's the main queue. But the second one here, this 2, is from a background thread for number 6. So your subject, whoever sends this, can decide on what thread he wants to send it, and all the work, for example, if you have here a very expensive map operation, which I'm not going to do here. I'm just going to pass the same. So you could do something really expensive here. Expensive. And since your value is 2 is sent from a background 1, you would do this expensive on the background. But this means that here, this value we need to, in order to put it on, to show to our users, we have to go back to the main thread. And obviously I could now here ask in my sync dispatch queue main async, but they actually added a operator to do this for us, because it's also nicer to decide at which point of our data streams do I want to switch, at which point I want to go back to the main thread. And this is the operator receive on, and you see here the scheduler. This is a protocol, and dispatch queue and run loop both conform to this. What I want to do is I want to use whatever I processed here and use it on the main thread. So I'm using here dispatch queue.main. So now here, this is going to bring me back to the main thread. So when I print this again, both of my numbers here, my 1 and also the 2 that is from a different thread, are in the sync received on the main thread. Sometimes you will get an error. So not in the playground, you don't see an error because now we don't put it on the UI. But if you use that in your project and you try to assign it to a text label, then Xcode will complain and tell you that you shouldn't do that. You go back to the main thread. The operator receive on switches whatever was before, comes back to the main thread afterwards. Which leads us to the next question. Because we have this nice data stream, I can say everything downwards is on this thread, but I can also say everything upwards is on a different one. And here's another operator that helps us switching threads, and that is subscribe on. And in contrast with receive on, subscribe on changes the thread of the upstream to the publisher. So everything that is executed before, we can say, okay, change the thread to a background thread. So this is not the most amazing example. So I'm going to show you a couple of examples because this is harder to see. We have here one more subject, one more publisher. And I did just subscribe to this publisher, and we are printing the values and again the thread that is executed. And in this case, we are just going to, again, sending 3 values down. So I want to change the thread from what's happening above. So maybe we do something really expensive before we receive or sync. So I'm going to use here subscribe on, and this is again the dispatch queue.global. If we run this, you see that we receive it again on the main queue. So we can decide what we want to do before and afterwards, or we can decide when we want to switch threads. But some of the publishers actually define or already said which thread they want to be on. So we have a look at one publisher, which is the URL session publisher. If you already work with URL session, you know that this publisher, or if you use a normal URL session data task, this is executed on a background thread. And similar, if you use here the publisher from URL session, this is also executed on the background thread. I have here a URL session that does a task for this URL, just some placeholder JSON file. And I'm here, you can also ask I'm here using map to again show what thread this is on, or in this case, I'm asking if it's the main thread. And then I have a simple sync subscription that again, I don't really care what this thread is giving me back. We just are caring about the main thread or the thread. So if you run this one, you see that both, when I call this map, it's both times not on the main queue, because our URL session data task publisher decides to be on the background thread. If I want to use this data now, we have the option to use here the receive on dispatch queue.main. This is good because then we can put it on our UI. We do some other stuff here like decoding before we go back to the main queue. So if you run this again, you see that my URL session is on the background, but after my receive on, I'm on the main thread. So the question is now, can I actually change the thread of this publisher? And if you try now here before this map, because I want to know if I can change the thread upstream, I'm going to subscribe on dispatchqueue.main. So we see if we actually change a thread here, the thread, and you see that this is not happening. Everything that is before, I couldn't switch the thread that my URL session and my data task here works on. This is because the publisher has the say of which queue it wants to run out. And my URL session always wants to be on the background, no matter what you set there, which is, I guess, good because you don't need to take care of this by yourself. And it automatically switches whenever you create a URL session data task publisher, it goes back to the background. If you had a publisher that doesn't specify which queue it runs on, we'll see also a little bit of how to write our own publisher. Then you can set the thread that you want to run on with the subscribe on. I will come back to this multithreading later when we also talk about fetching data and doing some expensive stuff. Just need to have some baseline because we are talking about publishers next. It's like also one of them that comes back soon is this URL session data task publisher. So far I talked a lot about subscription, and I try to use a very simple way of explaining this. And especially I said always that we create a subscription when we use here sync, assign, and assign to on. But there's actually a lot more going on. So now it's the moment of truth that I maybe have simplified things a little bit more. And I'm now going to explain you what's behind going on, because there's quite a bit that happens between our publisher and our subscribers, because I actually didn't talk about subscribers yet. If you go in the subscription pattern page, what is actually a subscription? A subscription represents the contract between a subscriber, which is our sync or assign, and the publisher, that was usually these timer publishers. A subscription is a protocol, and it actually uses also cancelable. And cancelable means it has to have a function cancel. If you want to create your own subscription, you have to implement also a cancel function. We saw this when we used our sync. Maybe I just go back. Here, this subscription that I get back, or what I get back is not the full subscription, I get only back the cancelable. They don't expose all the subscription what's going on, which is in order that I don't mess up all what the subscription actually does. But because I get back the cancelable part, I can still call here cancel on my subscription. What a subscription has to have this function cancel, and it does some cleanup work inside. What a subscription also has to have is a function request. And here it gets from the subscriber how much the subscriber actually wants, how high the demand of the subscriber is. And you see now that I have somebody at the end who's using these values, the subscriber, but maybe I overwhelm the subscriber. Maybe the subscriber does something really time consuming, and if I give him like 20,000 values per second, it's just going to crash. So that's why they made combine in a way that the subscriber decides how much values he wants. And the subscription is the mediator between the subscriber, sync, for example, and the publisher or time publisher. The subscription is the one that asks how much, you're the subscriber, how many values do you want? Okay, you want now 1. Then it tells the publisher, okay, you are allowed now to pass 1 value. The subscriber has 1 more value, so the subscription asks, you're fine with these values, you want more, you want to increase your demand. And that's what you see here. I have this is just the smallest part of a subscriber. So what a subscriber or the end user, what you saw in the sync is, it usually has something that it wants to receive. This is the input. And also it also has to say what kind of failure it accepts, like a error, or maybe it never wants to have an error. Maybe it says failure is never, like a sign. But you see here also a subscriber has one function, and you see here it's the receive. So the subscriber receives a value, and it has to give back to the subscription the demand. So subscriber can say, I'm okay for now, come back to you later. In order to see this better, what's going on, we're going to have a look. I'm going to use it's not necessary to know everything. Okay, so I have here the one slide from the .wtc presentation from 2019, Introduction to Combine, where they talked about this flow between subscriber and publisher. So I'm just going to recap this here, because I think it makes it a little bit easier to understand. So you have two things. You have the publisher or timer, and the subscriber, like a sync or a sign. When you add the thing to a publisher, what you actually do is you call on the publisher. What you do is you attach your subscriber, your end user, on the publisher, which means that on the publisher there's a function receive subscriber. So it's not subscribe, it's receive. They renamed this. So the publisher gets the subscriber, and when he has a subscriber, he checks, are my types matching with the subscriber? If yes, then he continues. Otherwise, you see an error, compile error. Once he has a subscriber, he creates the subscription, which is the contract of what values are passed. Since the publisher has the subscription is the one that talks between these two instances. So the subscriber has another function, which is receive subscription. So it gets the subscription, which also helps it to receive the values, or that's where it gets the values from. Then the subscriber has the subscription and can tell the subscription how much values it wants to receive, how high its demand is, or it's actually requesting from the publisher to get some values. Give me something. For example, this demand, you can say none. I don't want to have anything. It's limited, one value at a time, and then I will tell you later. Or it can be unlimited. Whatever you have, just dump it on me. Like, for example, sync is implemented like this. Once the publisher then knows how much values it's supposed to send, it can send the demand, maximum the demand, or less. Once it's finished, once it doesn't have any more things to publish, like our array publisher or sequence publisher, the publisher can say, I'm done, and it can send a completion. And at this point, the subscriber receives a completion notification or completion value, and this is only called once. So that's why you have here for the subscriber, what the subscriber needs to say. It has to have something that it wants to receive, a failure that it accepts. It has a function to receive a subscription, it has a function to receive a value, and it has a function that tells it, oh, the subscription is completed. There's nothing more coming. Apple doesn't recommend to write your own publishers and a subscription, because it's not so. You can do a little bit wrong, as you see here with this demand and handling. If you have a look now at one of the subscribers, which is here this assign, which is the failure type is never, because assign to on doesn't accept anything. And the way they added the subscribers is as an extension to the publisher. So you see here this functions assign, and you see here also this one, it returns any cancelable or subscription. So this assign operator is one way of attaching a subscriber to a publisher with a subscription. If you scroll down, you see here, this is the similar example that we had in assign and page. I have here a simple class with one property. We have here a class instance and a sequence publisher. And you see I can create a subscriber by asking my subscribers to for the assign of the object and the key path. And you see here, I take my publisher and I tell my publisher to receive this new subscriber. This is the function that we had really here on the top. The basic implementation for a publisher with this output failure and receive subscriber. When this is called, this publisher has to create a subscription, and it sends because it also gets here the subscriber, it can tell the subscriber to receive this new subscription. This is one of the functions that the subscriber has to have. And then this back and forth starts. Okay, if you go back down, so this is really, you see here directly that tell my publisher to receive a new subscriber. Right now, I'm using here the sequenced publisher and assigning it to change the values of an int property here. And I just added here, we just used this set property of server to see the new values. But I want to see more what's my stream going on. What I just said, with this receive, demand, subscription, completion, the back and forth between the subscriber and the publisher with the subscription. If you want to see more, you can use an operator which is a print one. So in the stream, at any place in the stream, you can add a print, and you can add here a marker that is always printed with this, so you know which position you're printing. And I'm going to add here a emoji, so I'm just going to add here a star, because then it's easier to distinguish between these two. So if you run this, you see that we start with receiving a subscription. This is, maybe I just need to bring up this slide here again. So we said when I attach a subscriber, my assign here to the publisher creates the subscription and calls this receive on the subscriber. So you see here, my subscriber receives a subscription of this sequence. Then my subscriber has to tell what demand it has, how much values it accepts, or it requests a demand. And you see this in this print statements, request unlimited, because we have here a class instance that why would this be unlimited? The assign doesn't limit it, which means that then the publisher says, okay, I will give you whatever I have, which is this free values. So it calls the receive. So the subscriber gets called receive and gets the values, and you see here receive value 1. Then the subscriber, we update here our value in my class, an int, which calls our property observer that set. The publisher publishes one more value 1, which the subscriber receives. Then the publisher sends one more value, which is the 2. And since it's done, it's then calling the received completion. And you see here receive finished. One of the reasons why I told you what's going on in the stream is so you understand this print statements better. We usually don't really want to write subscriptions ourselves and publishers. Apple made this combined frame in a way that it's usually easier to take the basic parts that are provided and try to combine them in a way that they make more sense. So they are usually the pieces that we get from the publisher and the operators are really smaller. You can use to do smaller operations, and then you compose them together to get a more complex workflow. I hope I didn't give you too much information, but it's just a basic understanding that we have a more complex contract between our subscribers and our publishers, and that the glue that puts them together is the subscriptions. So when I say, I'm probably just going to continue like this, when I say I'm using here as assign or sync, I'm creating a subscription with assign or sync. This is true, but you know now that I also say the subscription is one part, it's the main part of what's going on, but there's a lot of interplay here. Welcome to the second section, where we'll talk about publishers, or the someone who makes values in our stream. Who's going to do this, and what kind of options do we want to do this with? And this is really nice, because in the previous subscription section, I kind of had to pass comments going more into detail about publishers, so now we can dive into, which makes it's going to be a huge improvement when you want to work with Combine if you understand these basics. And you see here in this playground there's quite a bit of things, quite a few publishers to investigate. And there's basically two different categories of publishers. We have the subjects, or as you see here, publishers that continuously emit values, that you can also send values to, that are processed in a data stream. So we'll have a look at the two kinds of subjects, which are CurrentValueSubjects and PassthroughSubjects. And we also see how to create a publisher from with a property wrapper at published. And what we get with this at published is also a subject. So we'll have to investigate and dig a little bit deeper what this does. And since we already went through quite a bit of theory, it's definitely time at that point to have a demo. So we'll have a small to-do app that I'm going to implement in UIKit and also in SwiftUI. And the reason is there is a couple of things I want to demonstrate with these different subjects and what implications this has. And also we see more a real example of where this data flow comes from. The second part of these publishers is basically everything below. So these are publishers that emit a couple of values that are limited in what they emit. So you might have this, I already talked about this, sequenced publishers from arrays, but we have some more generic publishers like a just publisher, a future publisher, a deferred, an empty publisher, which it sounds a bit strange because this publisher actually never passes any value, but there is some specific use cases for this. So I will try to use them also in our little to-do applications. Then we have some publishers they added for the foundation framework. So already had this timer publisher. Then we see the URL session has a data task publisher. The notification center has also a publisher that we can subscribe to. And you have the possibility to add publishers to KVO instances, to key value observation. And we can use this to replace target action sometimes. This is especially interesting for UIKit, where we have to do more work to get our data streams going from our UI elements. And then the last, or actually I put this somewhere in the middle here. One part of this is the types of your publishers. And this is especially interesting if you want to create your own functions. A function that returns a publisher that publishes whatever struct, whatever file data you want to fetch. We are going to discuss the return type of these functions. What kind of publishers should this return? What do we want to do in the function? One thing that will help us is to type erase these publisher stream in the functions. And we have a look at this any publisher there. This is quite nice because it helps you to not have huge data streams, but have some parts that you can refactor and use later. So functional, quite interesting. So there's a lot to cover, and we'll start directly with the subjects now. I want to now talk about subjects, and this is a publisher that can continuously send new values downstream. And we have two subjects that we have a look at, and one of them is the CurrentValueSubject. What we can use this publisher for is like a property, like a var. It's a var that we have a publisher that we can subscribe to. I did add here 3 different examples for CurrentValueSubject. So first it's a current user ID that I defined as CurrentValueSubject. You have here in this triangular brackets, there are 2 things that we have to use for a publisher. We have to have a output. What is this? The output type. What is this publisher producing? What kind of values it's sending down? And here I said I'm sending down integers. And the second is the failure. And we use never when we want to say we never have any failures. I'm not planning to send down failures when I have a current user ID. When I create this publisher, I need to give it an initial value. Since I'm here passing integers, I need to define here integers. So I use 1000 as the current value of my user ID. Then we have a second example for usernames, and this CurrentValueSubject passes arrays of strings, because I would expect to have multiple usernames, so it's an array. And also, again, this publisher doesn't produce any errors, so the failure is set to never. My initial value for this usernames is an array of strings, so I have here Bob, Susan, and Louis. They are again the same type as what I declare my current subject should pass down. Then I have here the current user, which is a subject that produces users. And this is my own struct, my own model definition. And the user has an ID and a name. And again, I need to, because I'm using a current value subject, initialize this by giving it an initial value. And here I just use a user with an ID 1 and a name Bob. Now we're going to see how we can use this current value subjects. And the first thing is, what is the current value? Because if I want to use this as a property, I need to be able to access the property. So the question is, what is the current user ID? So I'm going to print now the current user ID, print current user ID. And if you take the current user ID, the current user ID is the subject. And in order to access the underlying value, the wrap value, we have to look for the value. So if you run this, you see that I get my current user ID 1000, which is the one that I initially set. Since I have a subject, a publisher, I want to also be able to subscribe to it. So in this case, I can ask my current user ID. And I can attach, because this is already a publisher, here all of our operators and our subscription like sync. And I'm going to use the one with the receive completion and receive value. So the first one is print completion. And I'm going to print here the value for the completion. And the second is receive value. And you already see that the subscriber uses the same value that the publisher is sending, because they have to match. So I will get here a int. This is my new value. And I'm going to print here receive value. Receive value. And then we are going to print this value. So if I run this, I get my first print statement from just directly asking my current user's ID's value. And the second one is executed because of the sync. At the moment, which I didn't keep the subscription. Subscription. That's why otherwise it will be only executed once. So the second is from the subscription that I created here. And the moment I attach here a subscriber and create a subscription, this sync already has one value that it can receive, or the current user, this current value subject has already one value that it can send. And this is the initial one, which is 1000. Which means that whenever you subscribe to a current value subject, it will directly send you the value, the current value. That's why it's called current value. So let's make this a little bit more dynamic by sending more values downstream, because this is this special publisher where you can also send values downstream, which you can do by asking the publisher. So this is our current user ID to send a value. So this is the one with the input. So I can say I'm going to change this to 1. And if you run this again, we have again these two print statements with 1000. But because I'm sending here a new value, this subscription, this sync, executes again this receive value closure, and we see the new value printed here. Usually, if you have this in the application, just going to print another one. And let's say you have a list of possible user accounts, and the user wants to choose one of them. He taps on it. And when you tap on this, you would change the current value of the user ID, the selected user ID. So when the moment the user taps on the item in the list, we would send this new value to our subject. And so the subjects are very useful for handling user interactions, or to starting streams from user interactions. Then the last one is, I cannot only send values, I can also send a completion to my subject. So our current user ID, I can send a completion. And here you have the possibility to even send a failure, but I guess we just finished fine. And if you run this, you see here that my completion handler from my script description is called, which means that, and because I said I'm telling my subject to stop emitting values, if you try to send another value, let's say 10, we can call send here, but it's not going to work. Oh, sorry. Send, not to send a completion. I'm sending 10. And you see that because my subject here completed, if I keep on calling send, it's not going to process them anymore. So we have an option to stop the stream, or all the streams that I attach to the subject. So we saw now that we have here this CurrentValueSubject that we use as properties that have a publisher. And you can send down whatever values that you want to, whatever model data that you want to. You can also send down a whole array if you subscribe now to usernames. So I'm going to change this here with this subscription. I will only see this once. And you see that indeed what this username is sending down is the whole array. It's not sending one element in this array, because I told it here that one thing that you hold is always an array. So I'm just going to make this go. Let's go back. We will use a lot of CurrentValueSubjects for our applications. They're really useful in starting streams and sending new values. If we now have a look at the second type of subject that we can use, which is a pass-through-subject. And as the name is passing through, this is used for sending values through, and you don't really have to hold a value. It's more a start doing something. And if you think about it, it's more equivalent to function calls to action processing. I have here a pass-through-subject, which is named new user name entered. You can see from the name it's an action happens. And what this pass-through-subject is passing is a string. It's the new username. And it's never sending failures. And the other thing that you see here, in contrast to a CurrentValueSubject, the pass-through-subject doesn't hold a value. So I don't need to have an initial value. It's basically a function call. And you can also see this if you try to access the value of this pass-through-subject, like for a CurrentValueSubject. If you try to use new user entered dot value, it doesn't have one. It does not hold a value. It's a different use case for a data flow. You want to start a data flow action. This is the main difference to CurrentValueSubject. If I want to do the other stuff is very similar. I can subscribe again. I can create a subscription and use my new username entered subject and get here my sync. So I'm just going to print here again the completion and the value that is passed. Receive value. If you run this, you don't see anything passed on because this pass-through-subject doesn't have an initial value. So it doesn't have anything that it wants to pass. After you created this subscription, if you send down a new value now, or if you want to start an action call now, you can again use send, and this is Bob. If you call this now, you see that we indeed received this first value that is passed through in our stream. And the last thing that you can send down is a completion, so you don't want to in the future do these actions anymore. For some reason you want to stop this stream, so you can again send a finish. In order to see the difference between this CurrentValueSubjects and pass-through-subjects, and in order to see better the use cases, I have here a small example in the next playground page. So in this case we have here a view model that holds an extra class that holds the information that I want to process, so I have them one nicely together. And this view model has two subjects. One is the usernames. This is a property, so we use CurrentValueSubject, and the value type is an array of strings for my usernames. And in the beginning, I only have one user, which is Bill. Then I have here a PassthroughSubject, which I want to use to change and add new usernames. That's why it's called new username entered. So if you have a little sheet in your application with a text field and the user types a new name and then presses on the create button, then we would want to send this new value downstream to our new user name entered. So this is a very tiny class. And what I want to do is I have here the task that when I add a new user, Susan, which I can do by telling my view model new user name entered.send. I'm going to send here Susan. This would be like an action call. So now what I want to do is, since these two subjects here, they don't interact yet, so I want to create my own little data stream that whenever somebody passes a new value in my new username entered PassthroughSubject, I want to add this to my new usernames. So I'm going to create a subscription to my new username entered, and we're going to use here sync. And when I receive this value, I want to add this new, actually I can just call this username. I want to add this to my usernames. This is the subject, and in order to send a new array of usernames down, so I have two possibilities here. I can change the value to be the usernames.value plus I'm going to add my new user here. This is one possibility, but I can also say that I can also send a new value downstream here, which is my usernames.value plus this new user that I have here. And you see again we have here this self, so I have to add here self, and I don't want to create a memory leak because right now in this closure I'm capturing self, which is my view model, and since my view model, my class here holds a strong reference to this subscription, they would be referencing each other and create a reference cycle. I'm going to use here unowned self, unowned self. I did create here a data stream between these two subjects, but I need to actually store the subscription. So I'm using here store subscriptions. I usually have here this subscription set of any cancelable because I might just add more and more. So just keep them bunched together. I update my usernames, but I want to also see that this happens. So what I'm going to do is I'm going to print the current value of this usernames, and I'm going to use here another subscription sync users, and I'm just going to print here usernames changed to users. And then this also I need to store in my subscriptions. So usually I see a lot of people who use a did set, a property observer. But since we are working with data streams, it's not really nice, and you already see here it's complaining because this is a var. If I'm not here changing the current value itself, I'm changing the value that is underneath. So if you have a publisher, you can just subscribe to it, and this is also a way of checking what's happening, of observing the property. Okay, now we have this little combination of our CurrentValueSubject and our PassthroughSubject. And when here I create my view model and my user enters a new username, and I want to see if my username array has now updated. So we run again. you see that the observer that I added here to my usernames was called once for the initial value, because this is a current value subject. And then it was called again because I added here Susan. You can do the same and add another username, which is, and you see we can update our username array here. You might now say, okay, from the outside, if you use this view model, you could also directly want to access your users and send here a new value. So I have here a nice way of updating this, because maybe I have something that I want to make sure that the user doesn't do. For example, I can add here a filter and say, if your username is too short, I'm not going to accept this. I can say the count of my name should be higher than 3, because otherwise it's probably not a name. If you try to enter something, this is not so much fun. Like if I try to add here now boo, you see, oh, I didn't finish this one. You see that this boo is not added because I stop here this filter. You see here when I look at this eyesight, it's like false, and this new user is not entered. So I can protect the way I handle this data nicely and decide what I want to do. But the thing is, right now I'm exposing my username subject to the outside, which I don't really want to. I don't want somebody to send this to. But I still need the outside world to know about the actual value or to subscribe here. Just don't want to have the send option. So in order to hide the fact that this is a subject that I can send something to, we can say that our usernames, and we can use here erase to any publisher. So this is let publisher. And if you look at what this is I'm going to print this here. This is changing by type erasing this current value subject. I end up having just any publisher. So the outside world, this publisher is not able to send anything. If you try to use here publisher send, you see that it doesn't exist. So this is a good option to do access control with publishers. So I'm going to here use this type. So I want to have here 2 different publishers, one that is private for this file, which holds my send values, and one that is public, which is usernames. So this is the one that I want to have public, and this is the one that I want to have private. And this is of type any publisher. Actually, this needs to be a var because I want to set it from the initializer. So in my initializer, I need to set this value here. So my usernames is my username subject erased to any publisher. And then I can make the subject that I don't want to use outside private. And now I need to here change this a little bit, because this is not what I am updating. It's not the usernames, it's the user name subject and the username. So this one I don't need anymore. So I'm basically having here an intermediate step of 2 different publishers. So from the outside, you see that if I try to access something from my view model, I can ask here to enter a new user, because this is this PassthroughSubject. And the other one that I have here is that I can access is this username, but this is read only, because this is any publisher, or in this case, it's a publisher. When I say read only, I mean this is a publisher that I can subscribe to, that I can use the values. So you see that this current value subject is a publisher with a special send function, which we can, if we want to, we can reduce it to just a normal publisher that only publishes. And if you run this again, you see that it's still working. we now have only one way of changing our user array. We come now to the next possibility, to create a publisher that you can emit new values to, that you can send new values to. And this is a little bit special because it is actually a property wrapper at publish that you can add to a property. And this property wrapper is going to create you a publisher that you can subscribe to. You should only use this in classes, not in structs. So I have here the same example as before. We have here a CurrentValueSubject for our usernames and a PassthroughSubject for our new username entered. And I want to now use my addPublished. And I said I can add a addPublished to a property that I want to have also a publisher. So this makes sense to use for the CurrentValueSubject, because this is a property which we want to have a publisher for. So I'm going to use it like this. If you just write a normal property without any special things, we would just say this is an array of strings, and we start with just having one element in this array, which is Bill. So we can now, to this property, we can add now this property wrapper, which is addPublished. Add sign published. Var. It's actually var, not just a let. So now I have also for this property a publisher. If you want to access this publisher, so we do the same as before, we have a look at how to use this publisher. As before with the other ones, with these other two subjects, we discussed how do you get the value, and this is essentially just asking for the normal property like before. This is our usernames. But the question is now, if this is the usernames, what is then the publisher? We can get the publisher thanks to this addPublished by saying $usernames. So this is now giving me a publisher of strings, of an array of strings. So since this is a publisher, I can subscribe and print here values. So the first difference to this CurrentValueSubject is that I'm going to access this differently, this publisher. I can also use, and then maybe I should store this in the subscriptions. So the next thing, I want to use the same with our update new user entered here. So we're going to subscribe again to a new username entered, and I'm going to use here sync. And I have here a new value, which I can say that self.usernames.append this new value. And because this is a memory cycle, I need to use here again a unowned self. And we need to keep this stream, so we need to store them in our subscriptions. You see here, I have added now to this property, to my new users, I changed the property itself. The question is now, okay, how does that work with the publisher? Because what's this publisher going to do? If you run this, we have to actually send something. So I have to go here to my view model, new user entered.send Susan. And you see that we had initially just one user, and then we're sending one more user, and our usernames array is updated. So you see that this publisher, whenever you change the property, the publisher automatically also sends this new value downstream. And the good thing is, because this publisher is only any publisher, you cannot send anything there. So if from the outside, as before with this, to protect it from the outside, if you want to use the view models usernames publisher, you cannot send anything here because it doesn't have it. We don't see it, the underlying publisher, what it actually is. We only see it as any publisher. But it's still sending something down. And this is why I am guessing that what they add in this property wrapper is actually a CurrentValueSubject. But what they only expose to us with this $usernames is a type erased any publisher. It's the same as we did by ourselves here. And I know that it might be a little bit confusing, but the basic reason why I'm actually talking about this is that you're not getting confused of what the hell is the difference between a current value subject and add published. They're also, it says published. This is not a normal publisher. Because I can still send here values downstream. Why would I need a current value subject? It's not a difference. It is the same thing with a different flavor. It's still something that you can continuously change and you can add, you can create data streams from. The nice thing about this publish is just easier for you to create a subject, a publisher from. You can write your code normally, that you could write your properties normally, just need to add a property wrapper. It's quite convenient, but there's actually more to this property wrapper. So the first thing, you can only do this with classes. And then the other thing, which I have here, so this is from the documentation, which is when the property changes, the value that it sends down is the new one, but the value itself, the underlying value, is only updated after. I know this is a bit complicated to understand, so I'm just trying to show you this now. So when I have here, I subscribe to my new usernames, I get my new value. Maybe I'm just going to print this here. But I can also check what is actually in the property here in this one. I'm going to ask my usernames directly, and I have to use yourself, which means I have to use your unowned self and self. So you would say like, okay, it doesn't really, it's sending the new value down, and you're just trying to see if the actual value is something different. That's weird. So just going to print this. We have here, the first time this is called, we have only this one bill username. So we print here the send down value and the value, the actual value. Then the second time we are adding here, we're changing this by adding one more username, which is Susan. And you see that we receive from this data stream what is passed down here, this value, which holds now also Susan. But when we want to actually look at what is in the value of these usernames here, this is still the old one. And that's what I mean here. This is what they are referencing in the documentation. This publishing occurs in the properties will set block. So when you have here this property wrapper, they use a will set. Just going to maybe have this here. So you have a will set. This is just for you, so I can show you what I mean with this. So what they are doing with this property wrapper is they are adding here a property of server, or one of the things they are doing. And here, since they are probably having somewhere in this property wrapper also a current value subject, they are sending in this subject value subject, they are sending the value, and only then they are actually, and you see when you're sending it first, and then the actual value will change. Just going to leave this here. Hope it's not so confusing. And doing the evolution of SwiftUI, they actually changed it. You had to, by yourself, add a little bit of did set, will set code. When we have a look at the demo, this is going to be a little bit more clear because it has some consequences. Right now, it doesn't look like there's a difference because, your status stream still has a new value. That's fine. Since I already mentioned SwiftUI, I want to talk a little bit more deeper about what the combine behind SwiftUI is. One part of the puzzle is this add published property wrapper, and it's specifically made for SwiftUI, which doesn't mean you cannot use it with UIKit code, but it has some consequences. So we go now in this SwiftUI specific page. I want to talk now a little bit about the combine that is built into SwiftUI. So if you go in the SwiftUI specific page, we have a very similar view model that I showed you just before. I have here two publishers. One is I added with this @published property wrapper, and the other one is the CurrentValueSubject. When you define this kind of classes, view model classes in SwiftUI, they tell you to use observable object or to conform them to observable object protocol. And what this does is it adds another subject to your class. So you can check this if you look at the view model dot object will change, and you see here it's a publisher, and you can call send to it. It's just yeah, they're hiding the type a little bit, or they're wrapping it in as a observable object publisher. But you see here, it's basically, since it has a send and we're not sending anything, it looks very much like a pass-through-subject. This is a nice little way of having a subject that is called whenever this class here would change. Because what it helps SwiftUI is, this is the way we automatically update our views. Because the view basically subscribes to this object will change and gets notified when it has to re-render or check if it should redraw itself. So this is the automatic data flow to the views to update them. So you have here this object will change. And now you're like, but in the code that you show, we never saw this object will change. And usually you don't need to do it by yourself, because when you have here when you add this @published, you not only create a publisher for this property, you also register your property for this object will change. In order to prove my point, I'm going to here subscribe to this object will change, so we see when this is actually executed. So receive sync. This is not giving me anything, so print object will change was sent. Let's subscription. So we see this print statement whenever somebody calls here object will change.send. I have here these two publishers, one with the @published. So when I change this one, I already said we should see an object will change publisher. So I'm going to say view model dot usernames dot append Karin. So let's run this. I have here a maybe I did add too many print statements. So right now we only care about these usernames. So I'm just going to take this one out, comment out the username subject. The first time this view model is initialized here, we already get the first time this update print statement. And when I create this, I didn't yet add my subscription here. So this first one is not going to be called. And then I add here Karin, and you see that my object will change is printed, and only then you see that my stream is executed. Although we never ourselves call object will change.send, thanks to this @published, it does it. As a comparison, in order to really prove this point, I also added here this CurrentValueSubject. So I'm just going to uncomment this and we try the same. I have here, I'm going to change this. I'm going to send a new value to the subject. So not to Karin. So my view model dot user subject dot send. So in this case, I cannot append it. In this case, I'm just going to change the whole array to Karin. So it only has one value there. You see from the last print statement that I actually changed this username subject. So I has the first one and then it just has the new versions. But my object will change never was sent. So it's clearly something to do with, it's clearly added because of this add published. One consequence would be that you're like, I cannot use current value subjects with my view models. That's not true. You just need to register for the same process by saying my object will change, self.object will change, because they expose this to us. We can manually send a object will change. And then again, our view would be updated. Okay, if I run this, it's not really going to, yes, you see in this case, yes. You see here this last print statement because I sent this update. I talked so much about these free publisher streams and their differences. And since we have this tool, we know now so much about it, we can actually jump into a real project and see where they come into play. And we will build the same project twice, once for UIKit and for SwiftUI. So you can really see what's going on and we understand more of the data flow. And the good thing is, since I have here view models, I can easily integrate them in both of these platforms. We will now start our first project. This is a to-do app. As usual, you always have to start with a to-do app. So we'll try to use combine for this project in UIKit. And in the next, just after this one, we'll do the same and create a SwiftUI project. Since there's a little bit more work involved in UIKit, I did prepare a sample project simply because I was adding some views and added some auto layout constraints. So we have here two view controllers. One view controller where we see the list of our tasks. Then you have down here an add button, which brings up this modal presentation. So you have here one text field where you can enter a new task. And then when the user presses done, we want to add a new task to our list. So then when he goes back to the main list, the main task area, he sees his new task. Right now this is not working because we didn't set up anything from our model or from our view model. So if you have a look at the view model folder here, I added a task list model. This is very similar to the classes that we worked on before. So I have here one CurrentValueSubject to represent the tasks, because this is a property. And then I have one PassthroughSubject to add a new task. And I just used the same stream that we just worked on, where whenever somebody passes a new value through our add new task, we check if it's long enough and we add this new item to our tasks array. So now we are going to integrate this view model in our view controllers. And we'll start at the to-do list view controller, because this is the main controller with the list of our to-do. So the first thing is I need to have an instance of my class. So at the very top, I am creating a task view model, which is an instance of my task list model. This is creating me these data streams that I want. Now I want to populate my table with this new data. And if you scroll down, I conformed here to the UI table view data source, and we have here these two required functions, which right now only have some dummy data, some mock data. So the first thing is the number of rows in the section, and we only have one section. So I'm going to return here my tasks view models task.value, because this is the subject.count. And then down here, when we need to create a new table view cell for this index, I ask also my task view model for the task, for the value, and we need to access the value at the index path.raw. So if we now run this, we should see already some of the data. Actually, I only added here one task item, which is buy milk. So this is the one that we also should see now. Yes, and it's there. So now I have this nice list. And the next thing I want to do is I only just added my data once, but I also want to reload my table view whenever my data is changing. Since we have here a subject, we can subscribe to any changes. I'm creating a data stream in my view that load. So what I want to subscribe to is my task view model, creating a data stream to my tasks, and I'm using here sync, where I receive here these values, which we don't really need, because what I want to do in here whenever the tasks are changed or updated, or they will send a new value downstream, which causes this closure here to be called, and then I can call and tell my table view to reload because there's new tasks. So since this I have to use here self, I need to use unowned self to not create a memory cycle. And then because I have here now a data stream, I need to store them in my subscriptions. So again, I have here a subscriptions property. So now we are repeatedly calling reload data whenever there's new data coming up, which is nice because then we always make sure that our underlying data is reflected in our UI, which we won't see yet because we didn't actually add new items. So for this, we need to work with our add new view controller here. So if we go in our add new view controller, this view controller, and I press the add button, I also want to add a new element, and I want to actually call in our view model here. I want to send a new value through our PassthroughSubject. So this view controller also needs to have access to this view model. So I'm going to create here a reference point, task list model, which is a optional task list model. So now I just need, when I am in my to-do list view controller, I added here a ZAG. Is called when I'm pressing on the add new button, so it creates the new view controller, add new view controller. So this is a good moment for me to give this new controller also the view model that it needs. So they are both using the same. So what I'm doing here, I'm handling my view, my class to the next view controller, my add new view controller. And since this view model here is a class, I'm actually handling a reference. So I don't need to, when I go back, handle back the data because they're accessing the same view model. So then in my add new view controller, I have now this task list model. So I also have my task and my publishers. I did add here a couple of functions. So we have here the text field, and I already added here this target membership. So we always see the right text in this text property. Then when the user presses on this done button, we can now ask our task list model that we want to add a new task and send the text. So this is the one, this is from the text field to store in this text property. When you press on done, it calls here the dismiss, which means that this view is dismissed. And then we go back to our task list. So let's see and run this. I start again with my one task here. I press on add new, and then I'm just writing bread, and I press done. This disappears, and you see here my bread appeared. Because when we add here this new task and the view model, we go here through our little data stream, we add this to our tasks, which is a subject, and our to-do list view controller does have a subscription to this task. So whenever the task is changed, when I press on the done button, then this closure is called and the table view reloads the data. So you see we have here a nice data stream that is initialized by the user whenever he wants to add a new item. And the nice thing is whenever you change here the tasks, so when you remove some of them, this stream here is called again to reload the data. Now we saw this works really nicely when we have here this CurrentValueSubject. And I already discussed earlier, there's a couple of differences when we have add published. So I'm going to change here this to a add published, and I already actually added the code, so very similar. The only thing is that it's going to complain a couple of places because I have here a value that it wants to, because I did use here, for example, a send. We don't do send, we do self.tasks.append new tasks, new task. To stop this because we have to change probably a couple of places. I think it's yes, in the to-do. In our to-do list view controller, this is where the other place where I access my tasks. Here, when I create my data stream, this task is now the property itself. In order to access the publisher, we had to use this $task. And then down here, when I'm asking for the count of the task, it's not the value because this is not the values itself. And the same here, I just have to take out the value parameters. So if you run this again, you see it builds. I just changed the publisher stream from a subject to a at published. So if I add new here a new element, this is bread, and then you see it's not there. Then I press again and I'm adding here butter. And now you see now only the last one is there. If you do this again, amazing book. You see again the last one. It always shows me, it looks like it's one step behind our data. So let's recap on the data stream. So in our table view, it seems, let's see what are the values that would be reloaded when I call this. So this closure is called whenever something is passed. So first I am now also going to print the values. So this is receive values. And I'm also going to print, because our table view is reloading, which means that the table view is going through this calls again. So it checks again if it has to add some cells, and then it will reload some of the cells. So, and in this case, you see what it actually uses is the task view model tasks. So BIU table is reloading data with, and this is my self.task view model.tasks. So, and I can just run this again so we see what happens. So we start off with having our one initial element in this array. Then I press on add new and I add here bread. So, and I expect here that, and I press done. You see that indeed this closure here, this task has the right values, the new values. It has now buy milk and bread. But my table view will not use these values. It will ask the values that are still in this task view model's tasks. It indeed doesn't have all of the elements. It's not loading the bread because the bread is not yet updated to the tasks. You do this again. I just add one more. You see that again the data that my table will reload is one short. It only has the last, it just misses the newest one. And the reason for this is, if you go here, so something is up with this at published. And when I just go shortly back here to our documentation, to our playground, when we discussed, when the property changes, the publisher occurs in the will set block, which means that the publisher the actual value is not changed yet, it will be set, but the subscriber receives already the new value before it's actually set to the property. And this is exactly what we see here with this. Our data stream here gets past the newest value, but if you try at this moment to access the value that is in our property, this is not set to the newest one. This explains our quite wonky behavior in our table view. It also means that working with these add published and UIKit is not ideal because it's actually made for SwiftUI. They put it in a way that it helps them to update their views. And they call it a specific moment so they can do their redrawing of their views. But here we do everything manually, and I was actually expecting to be right. If you want to change this and use here now this new value as a last proof, I'm going to create here a copy of our tasks. So this is an array of tasks of strings. Instead of using now the tasks directly from our view model, I'm just going to copy them here. So when this closure is called, I'm going to set myself.tasks to these values that I receive here. And now for my data, my table view, I'm using this new task array that I added here. Yes. So I'm basically creating another step. So this is nothing new, and I'm just going to add here bread. Now when we go back, you see it actually has the new one. It also has the one because now I control that I'm first setting the value and then I reload the table view. Instead of before, where I wanted to reload the table view before the data was actually changed. This is not the ideal solution, I guess, because you don't want to have too many copies of the same values. So we go back to the best version and working version. So I'm going to here go back to my view models data, and I don't need to have this copy anymore. And I'm not going to print all of these. And I'm not using the @published here with UIKit because this was not the ideal one. So my task list view model, just going to undo everything. So we again use here the CurrentValueSubject because this was different. It was first changing the value and then it was sending an update and passes the value downstream. So that was working much better with our UIKit flow. I just need to check how many changes I actually made. Guess I have to change this in my to-do list view controller. I subscribe to my task view model tasks, which is a subject. And then here, because this is a subject, I cannot directly ask it. I have to ask for the subject's value and also down here for the subject's value. The task views task value at this index path. So we just want to check if it's still working. And you see we have it now there. So it's quite nice. And we have the good thing about this approach is we put our data in an extra class in this task list model where we can do the main logic of adding these elements. And we have this one main funnel to add new items here. You already see there is a little bit of hints here we're going to add as soon as I talk more about future publishers. And not the future, but a future publisher. We're going to see how we can use that to persist our task list to the file system. So we're going to change this by reloading here the data from the file system, and we're going to add here another task because right now I'm just adding this new value, but we can create another data stream from our tasks that every time this is called, we're going to persist this to the file system. We'll include more combined in this project. The second demo that we are going to do is we are going to create this to-do app again for SwiftUI. And this one we're going to do from scratch, and we're just importing the view model when we need it because the views are quite easy to rebuild with SwiftUI. So I'm just going to leave this here and I'm creating a new project. This is an app, and in this case it's again a to-do app, and I'm going to use here SwiftUI for the interface, and I don't really care if it's the app delegate or a SwiftUI lifecycle because we are not going to touch this too much. First I will create a couple of folders here or groups. So this is my view model, and I'm just going to drag in the same task list model that we had before, because this helps us to have a nice comparison. So again, we have here our task and our task list, or add new task PassthroughSubject. Then I'm using here my content view to create this task list. In order to make this task list model work with SwiftUI, we have to use observable object. This is the magical one that I already talked about. And now in my content view, I'm going to add here this view model so we can see the list. And I'm using here a observed object property wrapper var task view model. And this is a task list model. So now it's asking here for the initializer for this value. So my preview now I have this also. And because I start off with this content view, my scene delegate, we have to go into scene delegate, and here in the UI scene will connect. I create one of these content views, and I need to add here an instance of my task list model. This is the view that is used for the UI hostings controller and is set to the window. So this is the only setup we need. Now I have in my content view, I want to have here a title. So I just need to rerun the preview. Probably don't need the minimap. So we have now here this default text, and I want to use this for this title. So this is tasks, and I'm just going to change the font to large title. I think it's the same as here. Now I want to add here a list, and we can also use the library. So this is on the top right. This is a list. So instead of table views, we have lists in SwiftUI. So I take this one and drag it below my task. So now I have here my task list. So I'm going to use for each of my, what do I want to show you? My tasks view models dot tasks dot value. And in this case, this is strings, so they're not identifiable. So I have to use here, I'm just going to say identify it by itself. I assume you don't have the same task multiple times. So I have here the task, and then I'm just using this in the text. So now we see here by milk, this is the one task I had. If you want to have this task like here on the left side, we can do that with the VStack. Oops. I'm just going to use here the SwiftUI inspector, and I'm using the alignment of leading. So now it's on the left side. Okay, the last thing I need is a new button down here. So just going to add here a button with the action. And we are going to say that the label of this button is add new, which is now in the bottom left corner. Okay, I'm going to add here a padding so it's not so squeezed. And I want to move it in the middle, so I need to have a frame. This is frame, and I'm using a flexible frame. Max frame. This is infinity, and the alignment is dot center, which is the default anyway, just so you know. Sorry, max width. Sorry. Okay, so now I use the data for my task for my view model here in my list, and I need to show a sheet or model presentation whenever this happens. And in SwiftUI, we do this with also another view modifier, which is .sheet, and here is presented, which needs a binding. I'm going to talk about binding in a minute more. So it needs to have a property that it can bind to. So on the very top, this would be a var show add task view. This has to be a bool, and it has to be, I'm guessing I'm starting with false, we don't show it. So if you use this down here, it's now going to tell me it needs to have this binding. And if you don't know SwiftUI, it's basically a in-out property that also handles more view updates. So this is with a $sign. It's the $sign is not a publisher. It's a binding. It's a bit annoying that they have the same, but it's kind of both based on data flows. This here won't work because we need to make sure that we have a special property, and this is a state property. State var. And actually this should be also a private var. So now it needs to have here a content to show, which I didn't create yet. So I'm going to create here a new file. This is a SwiftUI view, and I'm calling this add task view. Similar as before, this view also wants to have the view model. So as before, I'm using here this add observed object, which means I also need to use it in the preview. Just going to use the normal implementation, the standard initializer. Okay, now we need to, just bring this up, recreate this view. So I need 2 buttons and a text field. So in the library, I'm just going to add, actually it's nicer if I see the preview. So I can use this here for this add new task. with a font of title. So this is the system font, which I also used here for this text field. Okay, now I can here drag a new button below. I need 2. And I want this one next to the other one, so I need to have this blue line. So now they're next to each other, is a bit cramped. We're going to add some spacing soon. And now I need to have a text field, this one, between, so I have to look for the line, blue line that is just in between these two. So here it is. Okay. So the labels of these 2 buttons, the one is on the left. This is this one. We're going to name this the same as before, which is cancel. And I also want to have this pink color, so we have to change the foreground color. Color.pink. And the other one is the done button. So this is the content is a done. And just need to add here also some actions. If you want to have more spacing in between these ones, you can inspect the H stack with the SwiftUI inspector. And here on the top, it's spacing. So now I had here 1, maybe it's better with 20. Then I want to see this text field, because now it has no border. This is the standard way. Just going to add here a text field style, which is a rounded border text field style. And now it asks here for, and now it's complaining because we need to have here some special things again for this text field. And again here it asks for this binding. So I need to have again a property for this, which, because it's a text field, I need to have a text, so it's a string. So this is a var text, and this is a string, and initially we have nothing in our text field. So this is again the $text, because this is a binding, and because this needs the binding, it needs to have again a special property, which is at state private var, and the placeholder, I'm just using a task. And just as a last improvement of the UI, I maybe want to have a little bit of, I don't want to have it to the very edges, so at the end of this V stack, I'm going to add a padding of 30. Can even improve this more, but this is not the point. It's looking pretty much the same as this one. So let's just run this for the first time. Need to make sure I use a different simulator. Just using the iPhone 12 instead. Okay, so now we have the same view here. If I press here on add new, I did not bring it up yet. So in my content view, where did I set this? So yes, here when we had this sheet presentation, I didn't actually tell it what to show as the model presentation, but we just created the add task view, which also needs the same view model, or it gets now a reference to the same view model, because this is a class. But when I press on this add button, I actually need to bring up this sheet, which is connected to this property here. Is presented depends on if show add task is true or false. So I'm going to say show add task dot toggle. So it switches from false to true. So now I have here my table view. Press on add, and I can add here a new item, which I did not. So I can type in this text field, but I haven't added any actions to these 2 buttons. So we go back to the add task one. And the first thing is, if I want to dismiss this view, we can use the same state property as I used before here, this show add task view. But I don't really need to handle it down. I can ask it from a special place, which is the environment. And since I use one of the standard presentations, I can get it from there. So this is the environment. This is the presentation mode, var presentation. So this is similar to saying for view controller self.dismiss. So when I'm here on my done button, I can say presentation.wrapValue.dismiss, and I can do the same when I'm in the cancel. So now I can dismiss this view when I press on one of these buttons. But I want to actually create a new item, new task. So we do the same. It's nothing special. We can ask our task view model to add a new task and send a new value, which is now in this text here, in this text property. So let's try this again. So I have this, I go here, I add now bread, I press done, and you see it's not there. So the question is now, did I not add it? So in my task list model, here when I send this new task, I'm going to check whenever, and we are going to check how often these tasks here are updated. So I'm going to subscribe to our tasks. This is similar to adding here a did set print statement. Think receive values. So I'm going to print here values. Oh, sorry. Tasks were updated to values. So like this, we see if it's something wrong with our add new view controller. Oh, and I have to store this in the subscriptions. So this is actually a good point, because in the playground you don't see this hint. This hint is differently on the playground. Here you see a hint saying the results of this sync is unused. The results of the sync is any cancelable. So this is the subscription cancel, which it tells me you didn't use it, which it basically means you didn't store it. So it's a nice reminder to store it in our subscriptions. Otherwise I don't see my print statement. So when I run this again, we have here now our view. And then I go in my add new task and I add now here bread. I press here done. You see indeed my task here did get the right value, but somehow my view didn't update. And one of the magic things about SwiftUI, that it's supposed to be the one that updates everything all the time. This is because I did not follow the rules. And to prove this, I'm going to add a little bit of, I'm adding the thing that will trigger our views to redraw. We discussed this before. This is this object will change.send, which I need to have here self dot. So I have to use here again unowned self, unowned self. So we try again. So we actually didn't change anything from our data. We just triggered this one little function here. So add new. So this is bread, and now I press done, and you see it's there. And you can try this again. This is milk, and it's there. This is because this is a subject, a pass-through subject, something specific to combine that they need for SwiftUI. So we had to make here, how do I do this? To even make this worse for SwiftUI. So I said we had to add here this observable object. If I take this out, so you don't need to do this because I'm going to reverse this anyway. So I take this out, which means that this one doesn't exist anymore. See, it's not there anymore because this is the observable object thing. So now we get another error. We should. Yes, it's complaining. Sometimes it's nice if it's complaining. Here you see property type of does not conform to, you cannot use, okay, this is maybe a bit strange. It's basically telling us that whatever you want to use here with this property report does not work. So you're going to say, fine, not going to use it if you tell me not to use it. And then it's the same here for our add tasks. So we're just going to change everything to not use this special property wrappers anymore. So it's reloading. It's still there, so seems not to be a problem. and adding here bread, and it's not there. And although this looks like here I have a var that I can change and a class that I can change, and here I have it, my class values change, my UI stops reacting to anything that happens in my model. It just doesn't, the views are not redrawn or recreated when I change this here. So this is the magical binding of SwiftUI that we basically just broke. So the idea is, so what this observed object does is using a combined publisher stream to our model data. I'm just going to reverse this so we make it work nicer. So this is this one. Then I had to add here back my observable object. And then in my add task list, I have to, and here in my content view also using again this property wrappers. So what basically this add observed object property wrapper does is subscribe to this publisher streams that we start off with our view models here by making them observable object. And the thing that this is helping us is creating us this PassthroughSubject object will change. So where basically our view model has a publisher that publishes to the world something changed. If you care, you can just subscribe to it. And our views are the ones that care. So in our views, they use this at observed object property wrappers to access this PassthroughSubject. The subject did change, the subject will change, sorry. Which means that whenever it changes, this view knows we need to maybe redraw ourselves. We need to recreate some of our views. We need to check maybe somebody added an item to the list. So in this case, actually, SwiftUI is smart enough because it's state driven, so it knows all the properties that were there before to compare them to afterwards. And I'm guessing this is one of the reasons they used, because they need to do this comparison. This is why they used object will change, not object did change. So they have a moment to check what was there and what comes afterwards. Unfortunately, I'm not able to prove this, but they changed it quite a bit, so maybe it's not so necessary anymore. So you saw now this automatic publisher streams that they included in SwiftUI to bind the data that we have here in these view models to our UI. When I'm just going to bring up the UIKit version again. So one of the reasons why I'd like to have this comparison. In our to-do list view controller, here, in the view did load, we had to create this data stream ourselves to update the views. And you see here, I had to subscribe to the data of my view model and then reload this data view. What SwiftUI does for us automatically, so this kind of code would be quite repetitive to say, or check if my view needs to reload when this changes, check if this changes. This changed, reload, change this, reload. So it's nice that for SwiftUI, you don't have to take care of this to always update it again if something happens. You can, in the beginning, say, keep this value, this property, and this view always in sync. So even if you don't use any publishers in your application, you know that you at least use the PassthroughSubject. But they not only use this here for this property wrapper, for our view model, also this at state is one of the reasons we had to add this, because again, this property is used in our views and might change, and the view wants to know when this changes, so it also needs to have a publisher stream to know when it should react and redraw something. So that's why you have a lot of all of the values that might change during runtime. All the properties that might change during runtime will have to have some kind of property wrapper at state, at binding, a lot of things. So we did, to make this a little bit, to finish this, the last thing I wanted to do, after we now saw where SwiftUI comes in, if we go back to our task list model, I used here a CurrentValueSubject, and as I said before, so this is not the only thing I could create here. I can also use this add published So I'm going to take this one out and we try if maybe SwiftUI likes this one better. So let's see where I use this so I can redo all of my changes. So here when somebody sends a new task, I am saying myself .task.append new task. So we're not using this one anymore. And this is here this was the second subscription here was just for us to check. And I manually had to here send my object will change, which I cannot take out because this add published does this for us as one of the advantages. Okay, and I have to ask here for the publisher. So $tasks is the publisher. And I don't need this anymore. So let's hope I did not. Let's see. Yes, and I have a couple of more problems. Yes, in my content view, because I changed here now to a actual value, not the subject. I need to take out all of the places where I had task.value. Okay, this was only one place. So this is the other thing about these view models. I only need to change it once in one place. Okay, now we have our task list. Again, I add bread. And if I press done, it's added here. And you can add as many as you want. Butter. Done. Oh, I didn't press done. Butter. So you see, I didn't have to tell my list to redraw, because when I use a add published, and when I use here this add published, my views get automatically notified by this object will change for publisher, PassthroughSubject. That something happened and they might need to recreate themselves or be redrawn. Which also means if you don't have this here, which also means that all the properties in my view model, in this observable object, that you want to update for later, even if you name them here var, you can do this, you can change them, but the view would never react to them. So you end up using a lot of this add published. And in this case, our add new task didn't really, this one is not important because we never use this to directly draw on the views. We just use this to create our little data stream here. So to wrap it up, we used now quite a lot of subjects and new publishers to start our user interactions. And you will see a lot more to come, but if you get these ones, it's a huge milestone in using Combine in your projects, because now you know how to start a stream, how to use it, or to simply just observe if some of my values here changes by subscribing to the publishers and printing the new values. We will see more publishers in the upcoming sections, but they are different to these ones because these ones are the ones that we can use to start our stream, to inject values into our stream from user input, like when I try to add here a new element. Alright, you made it. If you liked this video, give it a thumbs up. It really helps me in what I'm doing. Also know this is part of a larger course and this is just a free part of it. You can go and check out my full course. There's a link in the description box. If you want to continue working Combine, I also provided a link where you can find some great resources and books. And as a suggestion of a roadmap, what you could do, you can go to the Apple documentation and just scroll, have a look at the different publishers and operators. Well, they all are publishers, our operators are all under the same hood, defined as a publisher in the publisher protocol. So you can just have a look at what kind of publishers and operators you can use. So there's some very convenient publishers like Just and Future, a results publisher, empty publisher. You can also have a look at the publishers that are integrated in the foundation framework, like the URL session data class publisher, the notification publisher, and the KVO publisher, for example. From the operators, there's a lot of them. So you can start, for example, with map operators, scan, collect, append, and the try version. So for functions that get a throw, you have always a try so-and-so operator. Since if you have a try, you can throw something, you can also start having a look at some of the operators that you can use for error handling, like catch, try catch, replace error, and map error. Then if you're interested into multithreading with Combine, it's a great tool for this. you can have a look at the scheduler protocol. I already talked a little bit about receive on and subscribe on. One of the most important useful operators and misunderstood operators or unused operators is flatmap. And there's also a newer version for iOS 14, which is flatmap maximum publisher. And this is nice because you can decide how many you can do batch processes, and you can decide how many you want to have, so you can decide how much concurrent you want to use with this maximum publishers. So it's a very great tool. Then one more thing where Combine can really come in handy, one of the advantages, maybe I should have talked about this in the beginning of this, so I could have motivated you a little bit better into learning Combine. One of the good examples is resource management. So you can decide how often you want to do a certain task or for which condition. So you can decide, you can do filtering, letting certain values pass. You can do that over a certain time interval. So you can use throttle and debounce. You can check that you don't do the same task all over again with remove duplicates. So it's really nice because since your data flow is unidirectional, you can just put in a little gate what are kind of values you want to keep on in your data stream. Then one of the big topics is testing and how to do a dependency injection. And for this, I would recommend you have a look at type erasing with erase any publisher, how to write functions, and also one of the convenience publisher, which is the results publisher. Then as another motivation to learn Combine, or as another motivation to continue working on Combine, is that we can actually take advantage of Combine a lot more in a lot larger scale. So some of the communication design patterns that are heavily used in Swift, like the Delegate protocol, the closures and observer patterns, you can try to consider moving from using these patterns to Combine publisher streams. Because you have combined publisher streams are basically observer pattern or event-driven updates. So it's really nice because it makes your code a lot easier to read and write. Instead of writing a whole delegate or closures, which can be a little bit difficult to understand where which data is going. We're not supposed to use delegate anymore anyway. If you take advantage of this communication data flow with Combine, it's a lot easier to write smaller components, to decouple your component into smaller entities, which would be one motivation to use MVVM. And Combine helps you to put up some wires between these entities with a very easy plug and play style. So it's quite convenient once you get a hang of it, and at this point you only need to use publishers like a CurrentValueSubject or a PassthroughSubject and use a sync or assign to subscriber to wire up these different components. So this is a very good use case from Combine, and this makes writing clean code a lot nicer. Combine can be a great tool if you want to improve the structure of your project or the architecture of your project. So there's a lot more to learn, and I'm pretty sure there's a lot more to come in the future for the Combine framework. And with this, I'm finishing. I hope I could motivate you to use more Combine in your own projects, and that you have now a clearer idea of what Combine is, how you can use it, and what you can continue on in the future. Have fun, happy coding. See you next time. Happy coding.